On this example, we get to help out a farmer that is trying to build a rectangular pasture with some fence, but he only needs to cover 3 of the 4 sides of this rectangle. All right, because the 4th side is this cliff wall. So what I'm going to suggest, just jumping into this, is draw yourself a picture. Just draw a rectangle, right? We know it's a rectangular pasture. So draw a rectangle, and then what I'm going to do is we only need 3 of the 4 sides. I'm going to kind of ignore this side over here. That's going to be a cliff wall. All right, from there, let's evaluate the other information that's given to us. All right, the farmer has 45 yards of fence. So it's a fixed amount of fence. All right, so I'm going to label the sides of our rectangle. I'm going to go ahead and say the X, that the top is labeled as X. And since it's a rectangle, the bottom has to be the same. So I'm going to label it as X as well. Up and down, let's go with Y for that side length. All right, now if we have 45 yards of fence, let's use all of that fence, and basically that would be adding up the side lengths. So that means we have 2 X's plus a Y should add up to 45 yards. All right, and then this farmer wants to have the area of 238 square yards. Okay, so we know an area is supposed to equal 238. Well, we have a rectangular pasture that we're fencing in, so we know we can calculate the area of a rectangle as base times height, or length times width, however you want to kind of visualize it. But in our case, what that's going to look like is the bottom would be X, the side would be Y. So multiply those 2 sides together, and it has to equal 238. Now, for a lot of students, this is the big challenge, is just going from word problem, mathematical modeling, over into some equations. Once we get to this point, we can follow what we refer to as the substitution method to help us solve this down. We sometimes call this, when we have 2 equations with 2 variables, we call that a system of equations. So let's jump into the substitution method. It's 4 steps, hopefully not too bad as we look at it. So we have our 2 equations. The first step is we want to pick an equation and solve for a variable. In our case, it could be either X or Y in either the left equation or the right equation. I try to pick whatever looks to be the very easiest to solve for. In my case, I'm going to say let's solve for Y in the left-hand equation, because all we have to do in that case is move the 2x to the other side. So if we subtract 2x from each side, combine these like terms, they go away, and we're going to be left with y equals 45 minus 2x. All right, so step 1 done. Next, on step 2, we want to substitute into the other equation. So what we mean by that is we've solved for y, so we're going to take what we've solved for here, and I'm going to replace the y in the other equation. All right, seems a little confusing at first, but what we're going to do is we're going to bring along the x, and we're going to replace the y in that equation with what it's equal to from the other equation. Okay, so y is equal to 45 minus 2x. Okay, we replace the y in the right-hand equation with what we said it was equal to from the left-hand equation. Okay, step 2, done. Next, we need to solve this equation that only has x's involved. Okay, we're going to solve for this remaining variable, in our case x. So to get going on this, what I'm going to first do is I'm going to go ahead and distribute the x from the outside of the parentheses and bring it to the inside of our parentheses. So it's going to get distributed to both of these terms on the inside. So we're going to have 45 times x will be 45x. And then x times negative 2x makes negative 2x squared. Bring along the 238 from the right-hand side. All right, now you may notice in this case we have our variable x is raised to the first power for that first term as I've written it, and the second power. So what that makes this is something special. We call this a quadratic equation. And we have some different options if we want to solve down quadratic equations. We could think of the zero product property, where you get 0 on one side and factor the other side. This one I think we could do that way, but if we want to think about it, there's another tried and true way, because I'm looking at that 238 and I'm saying 238 is a pretty big number. I don't know if I know exactly how to factor that off the top of my head. The other way we can approach quadratic equations is we can always pull out the quadratic formula. So what I'm going to do is I'm going to suggest we use the quadratic formula to help us out. Handily enough right down below here. All right, but if you were thinking about either zero product property and factoring or the quadratic formula, it's important that you have 0 on one side in both these situations. So to get 0 on one side, we need to move all the terms to one of the two sides. Now, I typically like to have a positive leading coefficient, so I'm going to move all of our terms to the right-hand side. You don't have to do it this way. If you move the 238 to the left side, you'll get to the exact same result. But to move the 45x to the right-hand side, I'm going to subtract 45x from both sides. As we combine these like terms, it'll make 0x's on the left-hand side. And then we will need to move that negative 2x squared to the right-hand side, so we're going to add 2x squared. Once on the left side of the equal sign, once on the right side of the equal sign. Again, as you combine these together, they're going to combine together and make 0 on the left-hand side. Now, what's going to be on the right-hand side? Well, I'm going to write this in descending order. We're going to have 2x squared, positive 2x squared. We're going to have a negative 45x, and we're going to have a positive 238. I like to go highest power to lowest power because that helps us pick out A, B, and C for our quadratic formula. Right? In this case, it goes ax squared, so A is going to be the coefficient on the x squared, that's a 2. Bx, so negative 45. And remember that negative, because it's in front of the 45, is attached to the 45. And finally, C is 238, the constant. Ax squared plus bx plus c. All right, all that remains in this case is we need to start filling into the quadratic formula. So that's going to be the negative of b, which is negative 45, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So I know I moved through that pretty quickly, but basically I'm just taking whatever we identified each of these as and plugging it into the formula. All right, from here we'd like to simplify down as much as possible. So the negative of negative 45 is positive 45, plus or minus the square root. And I got my calculator out for this. I did negative 45 squared, that's 2 negatives, so it'll be positive 2025 minus 4 times 2 times 238. Again, calculator came in very handy here. Not doing this in my head. 1,904. I can do the 2 times 2 makes 4 in the denominator. Got that. No problem. All right. Let's continue simplifying down what's inside our square root. So we've got 45 on the outside plus or minus the square root of 121 over 4. And this actually works out pretty nicely that 121 is a perfect square. So that'll reduce down to 45 plus or minus 11 over 4. But let's think about this. We have that plus or minus on the inside. What's that doing for us? Well, that means we have two different cases. We have 45 plus 11 all over 4. And we have an x equals 45 minus 11 all over 4. So two different cases. Let's go ahead and solve these down individually to get two different x values. So 45 plus 11 gives us 56 over 4, which further reduces down to 14. So one x value is 14. The other one is 45 minus 11 makes 34 over 4, which reduces down to 8.5. All right, so we've solved down for that remaining variable. That completes step 3. But we still haven't quite answered the question. All right, we want to substitute back into step 1 to kind of complete this. All right, so step 1, you may recall, was when we picked a variable, solved for one of the variables. That was this step right here where we had y equals 45 minus 2x. Now technically you could plug back into either one of the original equations. This just tends to be the very easiest place to go to plug back in. So what I'm going to do is go ahead and grab that and bring it down here to the bottom. All right, so we're looking at our nice equation here from step 1 where y is on one side. We need the dimensions of this fence. So the dimensions are going to be like an x value and a y value. We already have the x values over on the left-hand side, 14 and 8.5, but we need a y value to go with this. So to get that y value, what I'm going to do is use that equation from step 1, and I'm going to substitute in the 14 that we found here. So that's 45 minus 28. Just doing some simplifying down here makes 17. Or we could plug in 8.5. That would make a different fence. 45 minus 2 times, instead of x, we're going to put 8.5 in there, which is 45 minus 17 makes 28. All right, so either our dimensions are 14 by 17, x value then y value, or they're 8.5 by 28. So let's go ahead and bring those actually up here and just think about in relationship to our picture. And by the way, that did complete step 4. If we're thinking about our picture that we drew here, we could either make it 14 yards left and right by 17 yards up and down. Remember, this goes x value, y value. Or we can make it 8.5 yards left and right and 28 yards up and down. X value, then y value. Don't get confused that we use the x in the middle to mean 14 by 17. That's just a typical way to write dimensions. But I hope this helps out. Get comfortable with the substitution method. It's really not that bad, and always knowing where the quadratic formula comes into play is very handy. It's a very nice formula to utilize, and drawing a picture helps me wrap my head around things a lot of the time. So good luck as you're working on these. Hope it goes great.